systems of linear equations, engineering application, statics example. Again, students arrived at these two equations, most likely because of using sum of the force in the x direction, sum of the force in the y direction equals 0. We end up with these two, at least somehow. I assume that's how he did it. And we want to solve it in these different ways. This time we're going to do matrix algebra. So with matrix algebra, remember the key is we rewrite the equations using the matrix coefficients. A equals, and we just make sure everything's lined up, 0.7071 and the 0.866 and the 0.7071 and the 0.500. That's our coefficient matrix. Our variable matrix, that's simply T1 and T2. And our values vector, which are 0 and 95. The idea behind those being that we know A times X equals B, and therefore X that we're trying to solve for is the same as the inverse of the matrix times B. And if we remember, for a 2 by 2, if A is A, B, C, and D, then A inverse is 1 over the determinant of A times D and A. We swap those two and make these negative. And furthermore, remembering that the determinant of A is A times D minus B times C. Okay, so for our particular, so this is just reminders of how to do things. For our particular solution, then A inverse is equal to 1 over determinant of A times, maybe it would make more sense to do that part first. Let's, instead of compounding this whole issue, let's go and get what the determinant of A is. It's just going to be negative 0.7071 times 0.5 minus 0.866 times 0.7071. So the determinant of A, if we put that in the calculator real quick, negative 0.7071 times 0.5 minus 0.866 times 0.7071. We get a negative number, and that's okay. Negative 0.9659. So that's our determinant A. Our inverse of A would be 1 over determinant of A times, we would swap these two, so move the 0.5 up here, move the negative 0.7071 down here, we swap those, and then switch the signs on these. So if this one becomes negative 0.866 and this one becomes 0.7071. And that's how we would get the inverse of A. So our answer we know x is going to equal A inverse times b. So it's 1 over, and we can put this down here if you want. The determinant of A is negative 0.9659. Again, we don't really distribute that because in general we usually just have to end up taking things back out later. So we just leave it down there. So it's that times, I'm rewriting the inverse right now, 0.866, negative 0.7071, positive, or nope, this is negative also, 0.071. We have to multiply that by our 0 and 95. And the 0 is going to help make things a little bit easier for us. So 1 over negative 0.9659. We're going to leave that there. Alright, so to multiply matrix times a vector, try to get everything back on the page. This row times this column, so 0.5 times 0 plus negative 0.866 times 95. And for this one, negative 0.707 times 0 plus negative 0.707 times 95. So I probably should have moved down earlier. So we know that x has to equal 1 over negative 0.9659 times these things. I can ignore the 0 part, so negative 0.866 times 95 I get is negative 82.27, and the negative 0.7071 times 95 I get negative 67.17. I'm going to divide each of those by this 0.965, and so I get 82.27 divided by negative 0.9659. Whoops, I left out a negative. Just why I got the wrong one. So 85.17 and negative 67.17 divided by negative 0.9659 is 69.54. And so if that's what x is, remember that's the same as T1 and T2. So then T1 must equal 85.17 newtons, and T2 must equal 69.54 newtons. Again, best way to check them is put them back in the original equation to get the right answers.